Chapman-Kolmogorov, Part 2. Okay. This is the generalized version of what I was getting at the end of the last clip. So, this is going to apply to all I and j. In other words, for any starting state and end state in a system. What this says is that the probability of going from state I to state j, so from some starting state to some end state, which could be the same thing, in n plus m transitions, so in some number of transitions, is just going to be the sum across all of the intermediate states, all of the k's, of going from I to k, the intermediate state, and k to j, where you're hitting state k at transition point, or at interval n. So let's say we start at time 0, we're going to go from I to the intermediate point k at each of those points in between in between starting point 0 to the time of the finish, which would be m. So this is just adding up all of the probabilities of going from one path, going along each path, so going from one state to the next state to the next state to the finishing state on all of the feasible paths in the system for that number of transitions. So to calculate this, you have to have either a very good intuition about how you can do this in a lot of persistence, or you can just multiply the matrix by itself. So, for example, the probability of going from state I to state j in 4 steps is just the transition matrix to the 4th, and this is easy. It's most easily accomplished in MATLAB, and then you just have to read it.